We have 32 people. I would like to welcome everybody who has joined our monthly New Jersey Building Electrification Webinars. We have over 100 people, I think 101 probably and counting people who are registered. You probably heard that this webinar is being recorded. We're going to post the recording and slides on our website for benefit of all people, especially the registered ones who missed this evening meeting. And tonight, we're really pleased to be able to feature Matt Kavanaugh, who's been here on the show probably every few months, probably at least 3 times, maybe 4 in 2 years. And so he's just informed us that he is now the Chief Operating Officer of the New York-based INF Associates, which is a building and transportation decarbonization company. But let me tell you about his big project. He's decarbonizing heavy-duty tractor trailers and building out a $1.7 trillion charging network with solar PV and energy storage as well. They call it the evergreen charging systems. So in Matt's spare evenings, I hope he has some. He's available as an energy advisor to help guide you in creating a plan to electrify and decarbonize your home. My wife, Pat, and I and others probably will be monitoring chat. And so during Matt's presentation, be sure to ask your questions in chat. Matt, you're going to have to tell us if you want live questions as well. And then we'll do whatever we can do best to provide either a live or a written answer to your questions. So that was my short introduction. We're now up to 36 people and still counting. But Matt, I'm going to turn this over to you.
Okay. Thanks, Steve and Pat and New Sierra Club New Jersey chapter for allowing me to come on here. I have been on here a couple of times, and I'm really excited to share, some of the things that I've done personally to my house, but then additionally, the service that I'm offering through my company, Green Insight, to educate and inform and also consult on the payback and the carbon benefit of electrifying and decarbonizing your household. And the reason I say household is because we're considering your entire carbon footprint in this analysis, your cars, your lawn care, your heating and cooling, your electric, all those aspects that go into your household. So this is my contact information from Green Insight. Feel free to go to the website and check it out. And just a little bit about my professional career. I was in the Navy for 5 years, was nuclear submarines, and getting out, I started working as a reliability engineer for JCP&L and doing grid restoration, disaster recovery, sectionalization, fusing, and customer service, and then as well as low and medium voltage reliability. So there's a couple of things I learned in that tenure. One, the grid is very fragile and sensitive to weather events. We would pile into a war room every time there was a wind event or a snow event or a hurricane that came through, and we'd dispatch and work through the night to get the crews out there and restore power and put the lines back up. Second thing that I realized is that the linemen and crews that maintain the grid are aging out, meaning that there isn't a young workforce that's slowly trickling in to replace everyone that maintains the grid. And then the third thing that I realized is that to improve grid reliability, they do what's called sectionalization, which is putting fuses in all the circuits and branches along the road so that when there is an outage, it affects less and less people. And the ultimate extension of sectionalization means that if every home or every business could act independently, generate its own power, and also be off-grid or in island mode, that's the ultimate reliability, meaning one house goes down, but nobody else is impacted. And that's what I've essentially done for my home. And I wanted to share you exactly what that looks like and the process that I went through to get there. And then additionally, obviously some of the stuff that goes into consulting on this service. So why decarbonize? I'm sure we have a really good mix of people that can appreciate the facts on this slide, but climate change really requires everybody's action today. Global mean temperatures continue to rise year over year. The past 12 months have been suggested to be the hottest 12 months in 115,000 years. And September was one of the hottest months, well above 1.2 degrees Celsius. Atmospheric CO2 is rising above 400 parts per million. As of May, it was 421 parts per million. And this is up from pre-industrial levels of 260 to 280 parts per million. And then finally, the anthropogenic greenhouse gases caused by human emissions are not caused by the sun. This is the third graph here on the right, where solar irradiance has actually maintained itself, whereas the temperature has gone up. And it's important to remember that when we're talking about decarbonization and global climate change, there's a lot of information out there about what's true and what's not true. But I encourage you to do your own fact hunting and come to your own conclusions. But many reports nationally and internationally are suggesting that there's unequivocal evidence that it's caused by human emissions, burning of fossil fuels. So there's an important aspect of urgency, specifically in this decade. 2027, as you can see from this graph, is an inflection point where the globe should be 50% decarbonized from a standpoint of CO2 emissions to maintain a 1.5 degrees Celsius warming threshold. And the longer that we wait for any of this action, the steeper this decline has to be to maintain that threshold, which everyone agrees is an important milestone. But I also want to mention that, moving to 1.6 or 1.7 is much better than 2 degrees or 2.1 or 2.2 degrees. Every threshold that it increases is meaningful. So whatever we can do now to decarbonize in our personal lives, our professional lives, and as a society is going to be really critical to hedge that increase as little as possible and try and avoid extreme weather and climate change in the future. So one thing that I'm going to speak a lot about is geothermal, solar PV, and wind. And what I love about these is that not only are renewable energy sources clean from the standpoint that you can use the wind and the sun and the earth to move and generate thermal energy and produce power on site, but it's also cheap. Some estimates think that by 2040, utility scale solar could be 1 or 2 cents per kilowatt hour, which would be some of the cheapest energy humanity has ever seen. It's also safe. As you can see, in this graph on the right-hand side, the number of deaths from accidents and air pollution attributed to solar and wind and hydropower are extremely low compared to coal, oil, and natural gas combined turbines. And it's also abundant. In fact, roughly 1% or all of humans' annual global electricity could be covered if you were to capture 40 minutes of sunshine, the total energy of the sun for just 40 minutes. So it's incredibly powerful, and it also requires very little water. So this is also a nexus of climate change where not only is carbon emissions and energy going to be important, but also water will be important. And solar and wind, once they're in operations, use very little water as compared to thermal generation plants, which continuously use water and turn fresh water into gray water, which is unpotable. So that's going to be a critical point of contention in the future. And then additionally, it affords us energy freedom and resiliency. The solar power and the wind and the ground source heat pumps are accessible pretty much everywhere. That means that there's no supply chains. That means that once it's set and you're producing power, you don't have any fuel to move around. And additionally, these features are extremely resilient. In fact, the hurricane in Florida, there was a community that stayed online on power through all of that, and it was kind of attributed to solar and some of the energy storage and how resilient that community was. So it's been proven, and it's being proven time and time again. So I'll get into carbon and energy reduction with efficiency and renewables. In general, I'm focusing on households and homeowners because that's what my consulting does. But the path to decarbonize your home is really 3 critical steps. One, look at reducing your energy demand with home energy efficiency upgrades. So do an energy audit, understand what's available that you can put in place now. Insulation, new windows, doing a vacuum test on your house, potentially putting new insulation in your walls or your attic. That's what I did with my house before installing a geothermal. We put blown insulation in the attic. We did a thermal test and tried to enclose and cap off the building envelope, the house envelope, as much as possible. And then finally, what you're left with is a certain amount of electric energy and a certain amount of therms that you're using to heat your house and cool your house through kilowatt hours and all of your baseline loads. So the idea is that if you have solar available, solar resource on your roof or your property, try and offset all of that demand on premises with the solar and heat pumps, either air source or ground source. And then the balance can be offset with renewable energy, clean energy purchased through aggregation programs, which are available through your utility. You are able to purchase freely from any source through your utility. So you can choose, like I have, a 100% clean renewable resource for any electricity that you do draw from the grid that the solar or the wind or the geothermal doesn't take on. And I also have a ground source heat pump on my property. I live in a suburban community, so I have about a 25 square foot area on the side of my house that doesn't get any sun. It can't be used for a garden. That's where they installed the ground source heat pump. I'll show you that a little bit later. But the ground source heat pump is a really interesting feature, and it's one of the most efficient ways to heat and cool the house. And additionally, what I really love about it is that you can do it on your property by drilling down vertically, or if you have additional land, putting it in a pond, putting it in a well, or doing a horizontal system. And it has a very, very high coefficient of performance, somewhere in the 300% to 500% range compared to a natural gas furnace. So those are a feature I'll get into. Solar photovoltaics come in all shapes and sizes. In this case, I'll be talking about roof mount, but you could also do ground mount solar on your property if you have the land and the space for it. That tends to be a little bit more productive because you can orient it the right way. And then commercially, there's also carports and rooftops available. So I'll go through a case study just to show you some of the return on investment and the benefits of how quickly you can decarbonize by sharing 2 case studies, real life solutions. So the first one is what I'm calling the Kavanaugh Energy Master Plan, or renewable energy transition. And what I want to share here is 2 graphs, which really tells the story of how powerful these features are when you combine them together. So in 2018, I was using about 111,000 pounds of carbon emissions. So this included the gasoline I was burning in 2 vehicles, 2 internal combustion engine vehicles, the thermal energy burned from natural gas, and then also mixed electric energy from the grid, which was not carbon free. It was a portion carbon free, but not totally carbon free. So in 2019, we installed a solar system. That's that first drop in the bar that you see between 2018 to 2019. The solar system produced about 15,500 kilowatt hours of energy per year. It's a 13,000 watt system. So it gets pretty good production, and that lowered my emissions from 2018 to 2019. In the winter of 2019, we installed a ground source heat pump, and the heat pump was really critical in reducing carbon emissions. That massive jump down was also a function of moving to hybrid electric vehicles, so that the electricity consumed could also be covered by the electric vehicles. And essentially, I'm also tracking the net energy consumed or gross energy consumed. So if you convert the therms to kilowatt hours, the petroleum and gasoline to kilowatt hours, and you make everything kilowatt hours, you can also see that from 2018 to 2021, we dropped our total gross energy consumption by 80% and achieved a zero carbon footprint within 3 years. Now, I do want to mention I took out a solar loan and a geothermal loan. There's many different features for doing this. There are also solar power purchase agreements or leases, depending upon who you go with. I don't advocate for any specific company, but there are some solar panels and solar companies that are better than others. So, and then this entire graph includes electric, heating and cooling, transportation, and lawn care energy demands. And I have the lawn care is just this interesting little facet, but I think we all can appreciate how loud and polluting leaf blowers are, or lawn mowers sometimes. So I converted everything to electric so my solar system could cover my lawn care. And I use a brand called Ego, but essentially have leaf blower, snow blower, lawn mower, weed whacker. Everything I need for lawn care has an interchangeable battery. And in general, I use about 30 or 40 kilowatt hours of energy, for total property maintenance with those electric lawn care systems. So it's a small component, but it also saves a lot of carbon there too. And, from a cash flow standpoint, what's interesting about the investment tax credit that's available now and the Inflation Reduction Act is that, when I got the solar system and the ground source heat pump, they were phasing out this investment tax credit. They were dropping it from 30% to 26% to 22%, and then they were going to phase it out. But the Inflation Reduction Act actually extended that at a cap of 30% up through 2032. So it actually increased the subsidy, the tax credit you can achieve for ground source heat pump, EV chargers, and also solar systems. And so the economics would be even a little bit more improved in this cash flow. But on the left, I have annual expenses for all of my energy needs with a 3% inflation rate per year, and then the cumulative total. So over 25-year lifespan of these warranted systems, I would be spending about $240,000 or about $9,500 per year on average. Then in the middle is the costs of all the renewable energy features. And in the case of the solar, in New Jersey, I was grandfathered into the old SREC program. So I got SRECs for 10 years. Now there's a new program, which is actually a little bit more stable over 15 years. And then additionally, so you can see some of the annual cash flows bump around because the SRECs go away in year 10. And then the solar loan gets paid off in year 20. So you can see cumulatively, the total expenses for renewable energy transition is $80,000 or $3,200 per year on average. And what's really important about this graph is that when you install solar and you're producing your energy on site and your kilowatt hours on site, and you install ground source heat pumps or heat pumps, air source heat pumps, you're basically fixing your energy costs and hedging yourself against inflation. So year over year, if electric costs increase or therms go up, which we fully expect them to, as more resources are mined from the earth, you really have locked in your own energy costs, and you're not subject to that inflation, which accounts for the really good return on investment that you get over the lifespan of this equipment. So this entire plan breaks even around year 5. The total return on investment is about 8%. On an annual basis, the carbon emissions savings is about 1,400 tons of lifetime carbon emissions. So again, this includes electricity, therms of natural gas, as well as gasoline. I'm sorry. And the net cash flow from this entire process is $160,000 roughly. So, the investment tax credit in both cases you can receive the investment tax credit, use it as a pass-through to pay down the loans, and then lower your total cost instead of taking the tax credit yourself. So that's what I did in this case. And then some of the assumptions here was 210 per SREC for 10 years. Again, I said this is a grandfather program. Typically, you would replace your furnace every 15 years. So that's that red feature right there where I added about $5,000 of expense in 2035. But in total, you can see, you know, the lifespan of this system and the return on investment is very lucrative. So you can decarbonize at the same time as saving money and getting a return on investment in this day and age. And again, my house isn't very is average productivity. It's facing southeast, so it gets about 1.1 kilowatt hours per watt on an annual basis. But there are houses that produce a lot more based on the orientation. I have a couple slides on that in the future, but you can produce more solar and get a better return on investment. And as I mentioned, you know, I got the 26% tax credit, but now it's 30%. So the ROI here is going to increase. And then obviously inflation is going up. So, you know, the time is to act now for two reasons. One, you'll hedge yourself against inflation, but two, decarbonization is a critical priority and an urgency for everybody. And this is two graphs. On the left, it shows the cash flow. I chose to take a loan on the geothermal system over 5 years, so it was heavily paid off in the first 5 years. So the first 5 years were negative cash flow, but then year over year thereafter, I was saving all of this money. So we're expecting through 2044 to basically be hedged against all this inflation and the money that we'd be saving. And then on a cumulative cash flow basis, on the left or on the right hand side, you know, the break even point, as I mentioned, is about year 5.5. And then the total cash generated is $160,000. And again, this is a 3% inflation rate on the utility expenses. And then the vehicles, there was also an additional $15,000 of rebates for the two hybrid cars that we purchased. So that was not even factored into this. But I have a slide on the relative cost of running an electric car versus a internal combustion engine, which is a little outdated, but essentially it shows you some of the calculations on how much money you are actually saving by using an electric car as well. And then the ground source loop for the ground source heat pump, that thermal loop can last for 50 to 100 years or more. So not only is this equipment going to be extended beyond the warranty, and the solar system is still productive after 25 years, you know, the savings just continues to increase with the inflation in the future. So, you know, these are very good investments. The technology is viable right now. And when you start compounding and stacking these renewable energy features, EV, heat pumps, solar systems, energy efficiency, those things together can really create a lucrative return on investment.
Matt, could I interrupt? Just there's a question that has to do with what you just said.
Yep.
So it says, does the ROI assume that solar output of panels stays consistent over 30 years?
No, it accounts for a 0.25 degradation rate. So I have SunPower panels on my house, which are the lowest degradation rate in the industry, as well as the most energy from an efficiency standpoint. So the number of kilowatt hours per square foot is extremely high for these solar panels. But in this model, I did account for the fact that over 25 years, that solar panel will slowly lose some of the production. In the case of the SunPower panels, it drops to about 97%. So you lose about 3% of that original nameplate production.
Okay, we'll hold other questions till later on. Thanks.
Okay. Yeah, I mean, it is important to mention that you know, slowly over time, the solar panels will lose some of their production, but even at year 25, most solar panels will be at 95, 97, 93%. It depends on the solar panel, which is still extremely powerful and useful, especially if the system is paid off. So, you know, there's this aspect of you don't really need to replace the solar panels. It's still working, even after the warranty, and it's still producing energy. So you can avoid some of that waste that would otherwise go back into a circular economy with recycling the solar panels. And then I wanted to show you some graphs of the data that's coming off of this system. The blue represents the oscillation of daily production from the solar system. The orange represents the actual demand, electric demand. And, you know, the electric demands peaks in the summertime when the air conditioning load is very high. It goes down in the wintertime when the natural gas load is very high, so you can't really see that. But then in 2019, when we installed the ground source heat pump, the electrical load in both the summertime and the wintertime went down significantly. And the solar system covered both the EVs, the ground source heat pump, and the electrical consumption on site. So everything begin to be covered by the solar system. So summer peak demands are lower after the ground source heat pump was installed. In general, for this 13,000 watt system, the maximum output or production per day is about 75 kilowatt hours per day in the peak of July or August. In the depths of wintertime, when the sun is very low on the horizon and you don't get so much sunshine, it ends up being around 20 kilowatt hours per day, you know, in December or January. So it fluctuates with the sun and with the seasons. But in New Jersey specifically, there's net metering. So what that means is when you are overproducing on your property, the electricity or the energy will flow back through the meter to the grid. When you need it during nighttime, it will flow back to through the meter to your house to power your house. So it's a give and take. And basically any kilowatt hours you return to the grid show up as credits on your bill, and then you can draw upon those credits. So over an annual lifespan, on an annual basis, a properly sized solar system will offset all of your electricity if you have enough roof space. And then this is a Maryland case study, similar format. Now, we modeled this a little bit different. And Maryland has a different SREC program as well as some local incentives for heat pumps. In this case, the household was able to use a ground source heat pump, but go directly into an existing water well. So the cash flow is a little different, as well as year one and year two, they chose to keep the tax credits for the electric vehicles as well as the solar system and ground source heat pumps. So you see that huge spike in cash flow in year one and year two. And then essentially it's very low to begin with, but once you clear the loans, then the cash flow starts to increase. And in this case, the payback was 7 years and cash flow positive from year one, meaning you are saving money, but in year number one in this type of situation. And the CO2 from the heat, the cars, and the electric over 1 year went from 92,000 kilowatt hours to 17,000 kilowatt hours, and total carbon reduction of 100%. So what is a ground source heat pump? It's one of the most efficient ways to heat and cool your house. In my case, it was a retrofit job, but a ground source heat pump is a central heating and cooling system that transfers heat to the ground through vapor compression refrigeration cycle. There's commercial and residential applications. The ground portion is also known as a geo-exchange or an earth coupled or an earth energy system. So it's different from a pure geothermal system, which is based on pressurized or hot steam cycles that comes out of heat from the earth. So this is actually when you drill down about 6 feet below the surface, it is typically maintained about 50 to 55 degrees. So in the wintertime, you're actually extracting heat from the ground and putting it into your house. And in the summertime, you're running the loop in reverse, taking heat out of your house and putting it back into the ground. So you're constantly moving heat back and forth. And the reason that ground source heat pumps are so efficient is because you're not burning any fuel. You're just moving BTUs of thermal energy back and forth between the system. So 1 kilowatt hour of electricity or energy typically can move 3 to 5 units of thermal energy for a ground source heat pump. For an air source heat pump, that could be 2 or 3 or 4. So it's slightly less, but it's still advantageous to use an air source heat pump. And it takes advantage of the constant temperature. So it's really important to have constant temperature. That allows for a very stable coefficient of performance over time, either in heating or cooling modes. And we have found it to be very, very comfortable. It's operated really well. And even in the coldest nights in the wintertime, it keeps us nice and warm. And then in the hot days in the summertime, it has plenty of air conditioning capacity to keep the house cool. So what they say is just set it on 70 degrees or 69 degrees and let the auto system just take care of itself. And it's a really beautiful system. So our install was in 2020. This is a picture of the drill rig. It was on an F350, and they came in. It took them about a week, but they drilled 3 250 feet vertical ground wells with a single loop and then connected it through. And you might be asking, well, why does it take so much vertical pipe to do that? Well, the thermal dwell time inside of that thermal loop, as the water moves through, it needs time to absorb or extract the heat from the water. So that does take a little bit of time. So the water has to remain in the longer loop, depending upon how many BTUs you want to move back and forth. So if you have less thermal load, or your heating or air conditioning is less, then you wouldn't need as deep of wells, or you might need 2 wells or potentially 1. In my case, we needed 750 feet of well. And the installation took about 6 days inside the house. So before these images on the red was the natural gas furnace and the hot water heater, natural gas hot water heater, as well as the heat exchanger on the outside and the air handler in the attic. All of that equipment was completely replaced by the ground source heat pump, which you can see. The capped emission vent. So right now, the only therms I use is 1 therm per month because my wife won't give up her natural gas stove. So, but essentially, aside from that, we don't have any use for natural gas in our house. So the storage tank is like a thermal tank for the ground source heat pump. The ground source heat pump also powers hot water. So we get hot water from the ground. And then the pumps came in through the below grade through the foundation of the house. In a cooling mode, the cold water is pumped up to the attic air handler. And then there's forced cold air through the air conditioning system. In heating mode, it's a combination of hydronic heating pumps. So they basically use the baseboard hydronic heating, and they use hot forced hot air at the same time. So it's a combined system, and it keeps the house really uniform and nice and cozy. But all of this stuff was replaced over time with brand new equipment. And one thing I want to mention is that outside there is no noise. You can't tell that there's any ground source heat pump. This heat exchanger is not there making noise outside, so it's a very quiet system as well. And there's no components which are exposed to weather events or anything that happens outside, like a tree falling on the equipment. So it's actually very resilient and self-contained. And then a final feature that we put into our house was a sun vault system and energy storage system. So in 2022, to create that resiliency feature, we installed a 52 kilowatt hour energy storage system. Each one of those cases in my garage is 13.5 kilowatt hours of energy storage. And this pairs with the solar system and recharges during the day. In the case of island mode, so if the power goes down, this storage system backs up the entire house. And you might be saying that's a pretty big system. The reason I sized it that way is because I wanted to produce power for the ground source heat pump in the dead of winter when the solar production is very low. But we also have a electric demand to keep the house warm during the nighttime, during the winter time. And some of us have lived through some blizzard events where the power goes out, and it's just a really interesting situation when that happens, when you have no heat and you really come to appreciate it. So the 52 kilowatt hours will, with recharging through the sun, will basically keep the house warm and on in island mode somewhat indefinitely, depending upon how much other energy we use. And then the 10-year warranty on this battery system, there's a couple links here. This was called a Mega SunVault storage system. And there's a couple fun videos of that because it was one of the largest at the time when it was being installed. And then a little bit on EVs and the fuel savings. So when I say fuel, I'm talking about kilowatt hours of energy. But when I got my first hybrid vehicle, the Volt, a plug-in hybrid, it had a 70 mile radius on electric, and then the gas engine would kick in, so it was a hybrid. But mostly I drove it in electric mode, especially through COVID. And what I calculated, I looked at the electric miles, the electric consumption, the fuel economy. I tracked all this stuff. I was very active in tracking it, very proud of that early on. But looked at the total miles, the percentage on electric, the percentage on gas, and then the total gas price at the time to calculate the fact that the gas costs per mile is around 13.6 cents, and the electric cost per mile is around 5.2. So it's 3 times cheaper per mile to go on electric than in a fully electric situation if you're drawing and charging from your house at 15 to 16 cents per kilowatt hour. And on an annual basis, the net savings is somewhere between $600 to $750 because maintenance is low, and also with the fuel savings. And as we know, post pandemic, fuel prices spiked even higher than this, to $3 to $4 to $5, depending upon where you live in the country. So the economics improves even more dramatically when you start looking at higher fuel costs. And this is also built into that model where we're expecting fuel costs to inflate and increase in the future. So going with a electric vehicle, powering that electric vehicle with a solar system, fix your fuel costs for your vehicles and your transportation. And basically you're not subject to that inflation going forward. So you're hedging your entire energy ecosystem from some of the detrimental impacts of inflation. And then I wanted to mention something about solar. This is kind of, how much time do I have? So solar is somewhat requires a little bit of education just to understand how it works. It's going to be one of the most prolific energy resources in the future. It's inexpensive and accessible, as I mentioned, all those benefits early on. But and the efficiency of the solar panels is going to increase. But in short, it benefits from the photovoltaic effect, meaning that photons of light strike the solar material. It dislodges electrons and creates a small potential across the silicone, typically about 0.5 volt. All of those 0.5 volts are tied into series across a solar panel to produce a voltage on a plus and a minus. So this is DC power on a solar panel. And then each string of multiple solar panels added together creates an even bigger voltage. The DC power from the solar system is then converted into AC power through a microinverter or a string inverter that ties into your house. It connects with the grid, it balances and overlays on top of the frequency of the grid in terms of hertz and also the power load. And then essentially it matches up and you can't really tell the difference. And then, as I mentioned, when the solar system is producing during let's say you're at your job or you're out at work, the solar system is cranking away at noon, 1 p.m. All of that energy will flow back through the net meter to the grid. And at nighttime, the energy will come back and you'll be accruing credits for anything you give back. But there's really important performance factors because not everyone is a good candidate for solar. And it really requires 3 critical aspects: orientation to the sun, where in our hemisphere, south at about 30 degrees azimuth to the sun is kind of best case scenario. So if your home or a portion of your roof is directly south and it has a 30-degree tilt and you get a lot of sun, then basically you have one of the more beautiful roofs for solar. What that means is you are going to produce more energy per square foot as compared to someone who has a different orientation like my house. And the more off axis you are from south, your production will slowly go away. That's what this graph is in the lower left-hand corner. It shows you based on azimuth and tilt, sort of that sweet spot of maximum energy production based on where we are on the globe. And then shade, shade is the enemy of solar. So there's a really good sunroof project on Google. You can just type in your address and see how much sun you typically get based on satellite imagery. It's a really awesome tool to just check out your house. But low and no shade is best. Obviously, the more sunlight you get, the more photons of light, the more electrons, the more energy you're producing from your solar system. And then the location on the Earth is very important. High altitudes with a lot of sun are actually extremely productive. And the reason is there's less atmosphere for the sun to go through. So there's more irradiance that actually hits the solar panels at a high altitude with a lot of sun. So it's very, very productive. And then other areas like this heat map shows of the United States, the solar resource, the amount of sunshine varies very dramatically across the country. In our area, a really good solar panel could get between 1.1 or 1.2 kilowatt hours per watt per year. And somewhere in California or Arizona could potentially get 1.5 or 1.6. So about 30% more energy per unit of square of area. So, and then across the globe, it depends too. So, ideal situations is the higher the sun is up in the sky, as you approach the equator, the more energy is available for solar systems. And the reason that 30 degrees is good for our area is it's an average of the zenith to the sun. So in the winter time, the sun is very low on the horizon. And then in the summertime, it's very high in the 80 to 85 degrees. So 30 is kind of a blended average of those two, where across the annual basis, you get kind of the best averaging of the direct irradiance on the solar panel. So types of solar panels, there's monosilicon, polysilicon, and as you can see in this upper right-hand corner, the efficiencies of the solar panels continue to climb and go up and up and up. From 1975, you can see all the different types of solar panels. Those efficiencies continue to climb. We're seeing some really dramatic increases more recently with new technologies, and that expectation is going to increase. And some of the more interesting things that are happening with solar panels is older technologies were only capable of capturing visible light, but now they're working on the infrared spectrum and the ultraviolet spectrum. So depending upon how they're doping the materials and constructing these solar panels, now they can also capture energy that you can't see, but that is in different spectrums. And this image on the lower right-hand corner shows that curve is the total energy available, and the visible light section is only a portion of that. So what that means is that the solar system is capable of producing more energy per square foot, higher and higher and higher as you capture more of that energy. So really exciting things in store ahead. So the benefits of solar: it's clean, it's safe. The carbon savings are a fact that you're not burning fossil fuels. A kilowatt hour produced by your solar system directly offsets a kilowatt hour produced by a coal-fired plant or a natural gas combined cycle plant somewhere on the grid. So every single kilowatt hour that you offset with your solar system saves carbon emissions that does not have to be produced by a fossil fuel power plant. And that's where you get the carbon savings. And I want to mention something, that a solar panel is actually very efficient at saving carbon. In fact, one solar panel is roughly equivalent to a medium-sized tree. So from a carbon sequestration, so the amount of carbon that tree can absorb on an annual basis is similar to the amount of carbon that one solar panel can produce. So it's actually a very powerful method of sequestering carbon. And I mentioned it uses low water. So this interesting graph up on the right-hand side is a Sankey flow diagram. It's a beautiful diagram. It's one of my favorite ones, but it's the nexus of the gross energy demand in the United States versus the water system. And this big band in the middle is the thermal plants that are using fresh water to run through the thermal cycle to cool it down, and then turning it into non-potable gray water. So a huge amount of our fresh water is actually used to cool down thermal cycles in centralized power plants. And when you actually compare that to the public supply of water, it's astounding at how much water is used in the current fossil fuel infrastructure for centralized power systems with our current grid. So solar and wind do not use very much water at all when they're actually in production, and that has a huge benefit to society. When I was at SunPower, I led the end of life or solar recycling program. The solar panels that we were manufacturing, you could send them off and they would recycle the aluminum frame. They crush the glass, they take the glass off. They typically would incinerate or burn some of the stuff that they couldn't use, and 95 to 98% of that solar panel is recyclable. The copper, obviously, the precious metals can be recovered. And ultimately, there is a waste problem here that we have to deal with at a national level, but at least solar panels can be recycled. Carbon fuels and carbon emissions cannot be recycled. So at some point when we get really good at this, at recycling batteries and solar panels and the batteries in the cars, there is this opportunity to have a circular economy without a waste stream. And with enough materials, we potentially could stop mining for new materials and taking it from the earth. So that's the beauty of renewable energies as well. And then I mentioned it's very inexpensive. So levelized cost of electricity continues to go down. That red graph right in the middle shows the price of electricity from new power plants. And over 10 years, solar has dropped in price by 89%. Energy storage or batteries has dropped over 80% in that same 10-year lifespan. So those two coupled together are extremely economical right now, and they're going to improve. And one of the differentiators between energy that's produced from solar versus our entire energy history is that there's no supply chain, there's no fuel with wind and solar. And decoupling energy from a fuel is part of the critical nature of the grid of the future and how humanity will get its energy. So it's a really fun time. And then I mentioned it's abundant. So these circles in the lower left-hand corner show the total amount of energy from various resources. So the coal resources is that gray bubble, and this is in forgetting the exact number. Sorry, I got to get the unit of measure here, but the global energy demand is those little circles, the little globes in the lower left-hand corner. And then you can see the various sizes of different resources, solar being massive and huge and right in the middle. It has plenty of energy to satisfy what we need on demand. And there's enough sunlight that hits the earth in 1 hour to power Earth for a year. Another benefit of solar, it's distributed. So the current grid as we know it is that red grid where you have centralized power systems, huge transmission lines, step downs in voltages through transformers, and then finally the energy gets to your home. In the grid of the future, a lot of this is going to be microgrids, meaning that whether it's a single house or a single business or a grouping of houses and businesses or entire communities, these can have survivability and be off-grid and island mode and basically not be impacted because they can produce the energy they need from the ground and from the sun. So grid modernization is really critical as solar penetrates the grid. And there's a lot of discussion about how to do this, but what's exciting is what the grid is going to look like in the future when you have vehicles that store power that can communicate to the grid. You have solar systems, energy storage solutions that can communicate to the grid back and forth. And you have an entire ecosystem of resiliency microgrid power. And I think I'll stop there. There's more information in here, but I think I'm running out of time. I want to leave some time for questions.
Okay, let me, this is Pat. Let me just make one or read one comment and then we'll go back to the questions. Mike Winkus says, we just need a 20% larger system in New Jersey to generate the same amount of energy that is generated in California. That is why solar works everywhere. It is just an issue of space at the same panel efficiency.
That's right. I mean, some solar panels are 19% efficient. So what that means is that of the total irradiance, the photons that come from the sun, it converts 17% of that energy into electrical energy. Some solar panels are 20% or 22% or 24%. So they're just more efficient per square foot at turning irradiance into energy. And if you have a limited roof space on your home or your multifamily home, you know, that becomes a constraint where, you know, that limitation on space can only produce so much energy, even if you go with the most efficient solar panels. So there is a limitation there.
Okay, now I'm going back up to the top. When you mentioned lawn equipment, Holly asks, what was the brand of electric weed whacker, leaf blower, etc. that you?
It was EGO, E-G-O. You can find it in Lowe's and Home Depot.
Great, thank you. A couple of people asked about air source systems and heat pump systems, and one of them says, can you make a comment about using a heat pump to manage, and I assume he means an air source here, to manage climate in-house in mid-Atlantic area with very hot summers and very cold winters?
Yes,
and
so air
someone
source
else asks for more information on air source.
So air source heat pumps are a tremendous and amazing technology. They've come extremely far. Their efficiencies are increasing and the temperature range where they can be efficient is increasing to get lower temperatures, to get higher temperatures. So in the case of an air source heat pump, you know, when it's very hot, the air source heat pump is trying to take heat out of or put heat from your house in an air conditioning mode and put it into the hot air, right? So the hotter it gets, the lower the efficiency gets. In the case of cooling mode, it's trying to take heat from the cold air and pull it into your house. So the colder it gets, the less heat is available. So the spectrum of air source heat pumps depends upon the temperature range that you're trying to interact with. That's one of the advantages of the ground source heat pump, is that you constantly have the same temperature, 55, 50 degrees. Whereas an air source heat pump, you kind of have to deal with the outside temperature, which is highly variable, and it also depends on where you live in the country. But if you can't do a ground source heat pump, air source heat pumps are typically cheaper to install. But there's amazing technology now where you can electrify, get off of fossil fuels. And then if you have the advantage of using a solar system, you offset the electric load from the air source heat pump with a solar system. And then basically you get to that same carbon-free solution. So it's perfectly viable.
Thank you. Here's a question and a comment, or question and a reply. Jerry asks how much area is required to maintain a ground source heat pump, and Angus answered, it's usually in linear feet if piped at temperature. It's around 250 linear feet per ton.
Yeah.
And could you give an estimate of how much ground space that requires, land space?
Yeah, above ground. So the property where they drilled those 3 wells is about 20 feet by 20 feet by 20 feet. It's very, very small. And it's an area that's on the north face of my house. It's an area that's kind of dead space. I can't grow vegetables there. I can barely grow grass. So that's where we put the heat pump, and it was actually next to the side of my home where the furnace was and the hot water heater. So it worked out really well. But it doesn't take up much room, and you would never know, once the grass grows back, you would never even know that it's there. All of the pipe fixtures are fusions, meaning that they're not like glued together. They're actually the plastic is fused together. So it's actually a cohesive single loop that won't break over time.
Great, thanks. Shoshana asks, is it true that the solar storage batteries require some routine maintenance? What does that entail?
There is some maintenance in the fact that there are some moving parts, typically some fans that keep the batteries cooler if they get very hot. So there's some rotating machinery. So I want to mention that the batteries do degrade over time as you cycle them back and forth. Lithium-ion batteries, like the ones in my garage, they have a warranty for 10 years. But depending upon how much you cycle them and how deep you cycle them, there is some degradation in the solar capacity, somewhere between 10 to 20% over a 10-year lifespan. In my case, it's only in backup mode, so the batteries stay capped off all the time. When there's an outage, they kick in, so I'm not cycling them back and forth. But they don't have a lot of maintenance, I would say.
Okay, thank you. David asks, what do you do with your solar panels when it snows on them?
I let it melt off. Yeah, I'm not gonna, I have a 2-story house. I'm not getting up there to knock that snow off.
Okay. All right. Mike asks, could your battery system run a well pump, which is 3 horsepower, and your heat pump water heater with the initial surge? At minimum, I'm looking to be able to run my well pump and water heating if the grid goes down.
Yeah, so this is all part of the battery technology. You can size a battery for the amount of energy you store, and you can also size it for the peak power that you're expecting. In my case, I can do up to 8,000 watts of energy demand at any given time. That's how much power the batteries will put out. So it's perfectly fine for me from the standpoint of running the geothermal system and any other loads I have in the house. But you can you can size and configure the battery in a different way so you can get more power out of it. It just depends upon the manufacturer and the configuration of that system.
Thank you. Now I see that Angus has expanded on the snow on solar panels theme. He says, I wait for it to melt. They still work, but less production. Some people sweep, but I would never do that unless I was off grid. Loss from snow is expected and built into predicted production.
Yes. Yes.
Okay.
One thing I want to mention about solar panels is that they're dark. So typically the snow will start to slough off of them and expose little areas of the solar panels, which heat up faster than the roof would. And there's also air underneath it, so it doesn't produces a better opportunity for it to heat up and the snow to slide off. So what you'll see is if you see a solar system, a roof with a solar system, typically it's clear of snow way faster than a shingled roof, just because it will melt off faster.
Great, thank you. Christine asked, can you put Matt's business website in the chat? Which I asked her if she meant the greeninsight.green is, do you have a different website than that, or?
That is my business website, Green Insight. I could also provide INF Associates, which is, I'm a COO of that position.
Okay. Another comment from Mike Winka. New Jersey DEP is about to issue their guidance and requirements for EOL for solar panels. The issue is CD, which I guess is cadmium, and AG, that's silver, in thin film. They make that hazardous waste per the EPA TCLP test, but DEP could define them as universal waste. That's
Yes.
just a comment.
That is the interesting thing about solar panel and the way that they describe the waste. It depends on the state, and it depends upon who's testing it and what they find in the different test labs. In SunPower's case, we took everything to Arizona because they had a special facility that could reuse about 95 to 98% of the solar panels. Not every solar panel is produced the same way. They have different materials, different doping agents, as well as different chemicals. So the classification of the solar panel at end of life, EOL is end of life, just definitely varies by state. But the idea is we always moved it logistically as if it was hazardous material, just to cover our bases. So any carrier we got or any logistics freight load, we always had the drivers and the carriers so that they could carry it as hazardous waste. But I want to mention, you got to put hazardous in perspective, compared to the fossil fuel industry. So let's keep perspective on that.
Good point. Steve, I think this is for you. Angus gives his email and says, I love to talk projects. So maybe he's a candidate for a later webinar.
Yeah, I mean,
I will keep you in mind.
What I want to mention is, so what Green Insight does is exactly those graphs that I showed you. We pull your electric bills. I don't get sales. I'm a owner's rep for the house or the household. So I don't get a commission on sales. I charge a fixed fee and come in and try and spec out and see how viable your solutions could be to decarbonize and transition or electrify. What's the return on investment? What makes sense? And depending upon the situation, maybe none of it makes sense. So, that's the solution that I would give you is, hey, you don't have good sun, or maybe you can't drill here, or but I help you through the quoting process, evaluating contracts, putting it into pricing models and energy models, and really give you a hard subset of, does it make sense or doesn't it make sense, including all the incentives and tax credits. So there's a lot of things to put into the equation, especially if you're looking at someone's entire lifestyle. But that's the specialization that I've produced.
Thanks a lot. Thanks for that information. Eric says an interesting take on commercial scale batteries is, quote, Energy Dome, and he gives the website for that. That might be of interest to someone.
Yeah, at the end of my, in the appendix, I have several slides on energy storage solutions, which is a very broad-based topic, depending upon short-term, long-duration energy storage, gravity systems, flywheel systems, kinetic, thermal, chemical, electrochemical, mechanical systems. There's many different ways to store energy. And right now, it just so happens that lithium ion is one of the cheapest way to store energy, but that might change in the future. Especially with some of the more innovative solutions around pressurized water systems and flow batteries, gravity systems. So, I don't know if lithium will always be the solution, but and I also want to mention solid state lithium ion batteries are coming of age in the next couple of years. They have a 40 to 50% higher energy density per kilogram. And we are expecting the range on EVs to increase, stationary batteries to get better, and the cost to continue to go down. So it's a really amazing field, energy storage solutions, and it's very broad and complex.
Okay, here's a comment that Steve and I have been talking about. Jim says, air source heat pumps are now so efficient you can supply 100% of the heat for your house without any backup heat. No heat coils required.
True. I do want to mention that in the case of my ground source heat pump, we do have an emergency coil. So one time it did go down, and the emergency coil kept the heating system on in the winter time. So that having some redundancy is always a little bit good, even in the case of a ground source heat pump. But based on the efficiencies that they're seeing now with split air source heat pumps, it can operate in a really extensive range of temperatures.
Okay. Joanne asked, do you plan on replacing the battery on your Volt?
In a long time, I only have 25,000 miles on it. I mean, it could go up to 100,000 miles. So it might be another 10 years before I get there, at which point, there's a lot of discussion about reusing batteries in cars for stationary systems. So even after the life cycle of a battery in a car, it may have 70 or 80% of the energy capacity from the original system. You can take that out and use it for stationary systems in houses or businesses. So, there's an entire second-hand market for batteries from cars and other locations. And at SunPower, I was also in charge of their battery recycling program.
We've been hearing a lot in the last several webinars about how you don't need to buy a special battery, which is for your home, which is very expensive. You can just use the one on your car.
Well, yes. There's a lot of cars that are using, it's called V2G, vehicle to grid, or V2 home, or V2H, vehicle to home, or vehicle to building, V2B. In general, it's called V2X, right? vehicle communicating with something. And, some of the platforms like the Ford F-150 Lightning, right? It can provide 9,000 watts of backup power to your house and provide whole house backup system. So, 52 kilowatt hours may seem like a large energy storage system in my garage, but an F-150 Lightning sitting outside is 100 kilowatt hours of energy capacity. And in the future, the vehicle and energy storage in your house will all communicate with each other. So there may not actually be a need for a stationary system, very much like that comment suggests.
Okay. Eric says, I saw an article recently that, at least in the lab, recycled lithium-ion batteries were at least as efficient as virgin mined lithium-ion batteries.
I'd love to see that.
It's about quarter after.
Another odd take. Given that 10 kilowatt batteries are expensive, one wag said, just buy the batteries and get the car for free.
We have about 8:15 right now, Pat.
Yeah,
We
there are
probably should
11
call
new
it.
messages where I am. People have been putting things into the so the question is, do we want to go to the end of these messages, or it's time to stop at 8:15? How much time do you have, Matt?
Yeah, I can keep going. I love the questions. I
let
would
me
say
for
another
the people
15
that
minutes at the most.
for the people that joined in and expected to leave by 8:15, you can leave if you want. We will send all registrants copies of the slides, including the appendix and all this detail, plus the Q&A that you're going to miss if you do leave. All that will be, and the recording will be in email to you later on. So if you have to leave, thank you for joining us. So why don't we continue on?
Okay. Well, one of the questions is about that. How do you access the recording after the Zoom?
Okay.
So you'll get a link in your email. All right. And Steve also has given a link in the chat if you want to look at it. All house-related utility and IRA rebates and tax credits are summarized at this very long link. But that's in the chat, and you will get that also. And someone has commented correctly that for the first time in New Jersey history, it's now a lower cost to operate a heat pump than to use natural gas, oil, or propane, which is true. And we've talked about that with our own house. We save 20%.
And we're not done.
Last year, more heat pumps were sold than natural gas furnaces in the U.S. for the first time ever.
Yeah, I read that also. All right. So Holly wants to know, if we hire you, Matt, do you have companies you recommend if we want solar panels, geothermal, regular heat pumps, etc.?
Yeah, I kind of have a typical blend of, trying to price it out 3 ways, just so that we're looking at multiple quotes, and we have different service providers. So, but there are some better ones than others.
Okay. And Jim at comfortablehomes.com says, I can answer any questions you have concerning the benefits of cold weather, high efficiency heat pumps. Those are air source, I assume. And Joanne says, the Chevy Volt replacement battery is $12,000. And she has 78,000 miles on hers.
All right, I'll keep that in mind.
Oh. Jim Price to everyone. During COVID, we could not get the emergency backup coils, so we did not install them, but left the ability to add it later if needed. Turns out, all the way down to 5 degrees Fahrenheit without backup coils, none of our customers without the coils could not heat their house. Accidental test case, but it proved the coils were not required.
Let me have a little sidebar on exactly that. In Maine, they did an experiment, a controlled trial. They removed the auxiliary heat from all the houses, let the houses go from a large number of customers who willingly did this. And there were no complaints for a winter. So the answer is yes, you can do probably most winters without the emergency backup. But your house has to be well insulated.
Mike says, does your battery system account for the days that there's less solar resources and snow on the panels? How long can you operate on your battery system? That's for you,
Yeah.
Matt.
So the ground source heat pump system consumes about 20 kilowatt hours per day if you're running at full blast. Then there's some electrical loads. So if I keep everything on and I'm generating no solar power, I'll probably run out in a day and a half, even with a 52 kilowatt hour system. So it's not indefinite if the solar panels are covered and you're trying to keep all the loads on.
Great, thanks. Steve, this question is for you. Angus says, I'm not sure how I got signed up for this meeting. What is the organization running this meeting and how do I get on the list?
Angus. Send emails to Steve Miller at Comcast.net and I'll just put that in the chat to sign up. We have a 50 by 30.
We have several sponsors.
We do. We have several.
Sierra Club is one of them. Climate Reality is one of them. We're a committee on each of those, and then we have some other. I guess the main one for this is the Building Electrification New Jersey team. But Steve will put you on the appropriate one, whatever that is.
Yeah. So I need to know if you're going to be an activist. I have a special list for activists. If you just want to know about these building electrification webinars, I have a special list for that. So let me know. But I put my email in chat right now. Let me know if you'd like to join either or all of my lists.
And Angus also answered a question that someone else had asked. Electrification basically involves winter loads. The grid is most used in the summer. Heat pumps do not add to overall maximum load. And also he says, I'm on the board of New Jersey Clearwater org, so I'm interested. Put me on all the lists. I'm not sure you want to do that because I'm on all the lists and I get an awful lot of emails from my husband. Okay. Right. I think there's just one left. This is from Mike Winka again. The grid will go through updating and expansion to meet load because it's required to meet load by state and federal laws. The question is, are we going to do this in a planned manner or by the seat of our pants? Smith has a bill this lame duck session to require grid planning, which for some reason the New Jersey electric utilities have not been fully supportive. of in the past, but that may be changing. So FYI, we will get grid update. We're just not sure how it's going to happen, and no one seems to be sure how it's going to happen.
Yeah, I want to mention something about the grid. So in the case of my house, for example, the solar system produces 15,500 kilowatt hours per year. I consume somewhere between 17 to 19,000 kilowatt hours per year. So I'm only drawing 2,000 to 3,000 kilowatt hours per year through the grid. So the idea in trying to decarbonize and electrify and create that energy ecosystem is to create a system that is almost a 0-point energy impact on the grid. So you're trying to actually remove the load from the grid by using renewable energy instead of adding to the load. So even with the electric cars, I use about 3,000 kilowatt hours per year per car. That's covered by the solar system. So with electric cars, the ground source heat pump, everything is covered by the solar system. So, and that's an ideal situation if you can actually achieve that.
Okay. I'm going to stop after this one because I don't see anything else. It says even EV cars will end up helping the grid. EVs will be used as backups.
Yes, whether it's a school bus EV or a tractor trailer or a semi, a pickup truck, this vehicle to grid and vehicle to building aspect, these are what's considered distributed energy resources, similar to a stationary energy storage solution. It's going to be a solution that will communicate and work with the grid and work with the house. So it's actually it's a really good resource for the grid of the future.
Well, thank you so much, and thank everybody that participated in this discussion. It was a really fun discussion, and Matt, the information you gave was very much appreciated.
Yeah, I'm happy. Thank you for having me. I really appreciate it. Nice to meet everybody, and thank you for the opportunity to present.
Thank you, Matt. That was a lot of material. Everybody who registered will get that in the email links. And I invite you to our next monthly meeting on 1 month, December 21st. And we will have 2 townhouse owners, 2 case studies in their respective New Jersey communities of all the trials and tribulations and finally triumphing with what they wanted for electrifying their townhouses. So I hope you join us then. Thank you for joining us tonight.
Okay, thanks everyone.